So my musical guest band person thingy called in sick. So instead we're going to start our lesson with a joke.
Hey, why did the two fours skip lunch? You guessed it, because they already ate. Those two fours, they're always up to something. That's good. That's good.
Now we are ready to start. And this is our last little bit on rational expressions. Nothing new in terms of material here. We're just going to do a word problem or two. And I can't give you a better hint than what I'm about to tell you. You are going to see a question like one of these on your test. So we're going to use our knowledge of rationals, and we'll state some restrictions too if we have to. So our first example, Peyton can finish the unit homework package twice as fast as Maya. But working together, they can complete it in 5 hours. How long would it take each one of them to do it alone? Now, if you're wondering why is this a rational problem, because it involves a rate. And the rate is the number of packages per unit of time. So I'm just going to start there. And packages per unit of time, which in this case is hours. Let's build a roadmap. This is a thinking question, so let's build a roadmap. And our roadmap's going to be like this. Peyton plus Maya equals, and it says if they work together, so that's Peyton plus Maya, if they work together, they can complete the package in 5 hours. So one package in 5 hours. 1 over 5. One package in 5 hours. Now we got to come up with the rational expressions for Peyton and Maya. First thing, who's faster? If Peyton can finish the unit homework twice as fast as Maya, that means that Peyton is faster than Maya. So let's say Peyton can do one homework package in X hours. That would mean that Maya, so if Peyton goes twice as fast as Maya, that means that Maya is 2x. So she could finish one package in twice as long as Peyton. And again, that would equal 1 over 5. Now you could, if you wanted to, you could set this up with Maya being 1 over x, and if Peyton finishes it twice as fast, that means she finishes it in half the time. You could write Peyton as 1 over 0.5x. But that does kind of complicate things. It's bad math form to have decimals and fractions mixed together. So then you'd have 1 over 1/2 x, and now you got fractions and fractions, and that's just mind-blowing stuff. So we're going to stick with this. And again, if you know the magic of these pre-recorded lessons, if you need some help or you want to go back, you can rewind and re-listen to it if you need some more time to kind of comprehend how we came up with 1 over x plus 1 over 2x equals 1 over 5. And this is just adding a rational. So, and we got to solve an equation. So this is going to borrow some ideas from grade 9 and grade 10 as well. But before we get there, to be able to solve this, I need to set it equal to 0. So I'm going to have 1 over x plus 1 over 2x minus, because you're going to bring that 1/5 over, equals 0. Now I need a common denominator, and hopefully we're all professionals at this by now. What's the lowest common denominator between our coefficients? 1, 2, and 5. That's 10. And then 2 of them have an x in it. The 5 doesn't have an x in it, so 10x. What is this missing that this has? Well, that's the 10. So really we do times 10, and 1 times 10 is just 10. How do I get from here to here? We'll multiply by 5. Okay. 1 times 5 is 5. And how do I get from here to here? Well, I got to multiply by 2x, because 5 times 2x is 10x. And negative 1 times 2x is negative 2x equals 0. Let's do some simplifying on top. Collect like terms. Negative 2x plus 15. And to be able to, whenever you have a fraction, we know the bottom can't be 0. So for a fraction to ever end up being 0, that means the top has to be 0. So we can just get rid of or eliminate the bottom. Now, if that rattles your mind, think about this. If I was to cross multiply or multiply both sides by 10x, that would get rid of this. If you think of 10x times 0 cross multiply, anything times 0 is 0. That is a very simple equation that we all learned how to solve in grade 9. I'm just going to move the negative 2x over so it becomes a positive. Divide both sides by 2. X equals 7.5. And x, remember, represented Peyton's time. She can do one package in X hours. So this is really Peyton's time per package. So to answer our question, how long does it take Peyton and Maya to do each alone? We've already done all the hard work. X went with Peyton, so therefore Peyton can finish in 7.5 hours. And Maya, well, if Maya is double, which this was Maya right here, 2 times 7.5, 15. So and Maya can finish in 15 hours. So alone, Peyton takes 7.5, Maya takes 15. If they work together, it takes 5 hours. So there's example 1. Our second and final example. Two computers working together, for all the computer nerds, that's known as parallel processing, can solve the secret of the universe in 20 minutes. So they're pretty powerful computers. Alone, one of the computers can solve the problem in 9 minutes, less than the other computer. How long does it take the faster computer to solve the secret of the universe working by itself? So again, this is a rational because it's a rate. And what is that rate? Well, it would be secret of the universe. In some unit of time. And I gave you minutes, so this is minutes. And I didn't give names to this like Peyton and Maya, but if we want to build ourselves a roadmap, I'm just going to say the faster computer plus the slow computer, or slower, I guess we'll say, equals, and the rate would be 1 secret of universe completed in, what did we say? 20 minutes. Now the faster computer, it says, can do it in 9 minutes less. So if the slower computer is 1 over x, and if the faster computer can do it in 9 minutes less, that means the faster would be x minus 9. 9 minutes less. And that again equals 1 over 20. There is a second way to set this up. So if you're really with it, you're paying attention, you're getting this, you could have set this up as the faster computer being 1 over x and the slower computer being 1 over x plus 9, meaning add 9 minutes. And you'll get the exact same answer that we do here as well, if that's what you were thinking and you want to try it. This is adding rationals. We just did that. And we're going to set it equal to 0 so we can solve it. So 1 over x minus 9 plus 1 over x minus that equals 0. Now we need a common denominator, which means we need one of everything. We need a 20. We need an x. We need an x minus 9. What's this bottom missing that this has? Well, it's missing the 20 and the x. So this would be times 20x, 1 times 20x, 20x. What's this bottom missing that this has? The 20 and the x minus 9. So that would be times 20x minus 9, and times 1 is just going to be that. Minus, what's this missing that this has? Well, it's missing the x and the x minus 9. And minus x minus 9 equals 0. Now at this point, just like before, you can technically get rid of the denominator because the only thing that will make a fraction 0 is if the numerator is 0. Or you can think of cross multiplying, then anything times 0 is going to be 0. So I'm going to stop writing the denominator, we don't care about it anymore. And I'm going to simplify our numerator. So 20x plus 20x minus 180 minus x squared plus 9x equals 0. And I'm just going to finish off over here. Collecting like terms, that leaves us with negative x squared plus 49x minus 180, and that all equals 0. Now going back to grade 10, whenever you see equal to 0, that means you have to find your zeros, your solutions. And to be able to do that, that means you have to have it in factored form. How do I get to factored form? Well, I got to factor that. How do I factor that? Well, let's start out by removing a common denominator, which whenever the leading coefficient's negative, you should try to take out the negative. So we're going to do that. X squared minus 49x plus 180. And that is a simple trinomial. And well, it's simple in the sense that the leading coefficient is just 1. It is actually factorable. It does factor to be nice numbers. So two numbers that multiply to 180 and add to negative 49 actually are x minus 45 and x minus 4. Now, if you didn't know that, that's perfectly okay. You could have used the quadratic formula and you would have had whole numbers like that. So our two solutions, x equals 45 and x equals 4. Now, one of those solutions doesn't make sense in the context of the question. So x does represent time. Okay, so x does represent time. If I was to try both of those, so let's just say, for instance, this is what you should do. If you were to try both of those, you would find out that, so let's say we try the 4. So let's look at this one first. If I was to plug that into here for the faster computer, it would be, we're going to do this off to the side. If I was to plug that in, I would get that, and then I would get 1 over 4 minus 9 is negative 5. Well, how could the faster computer do it in negative 5 minutes? You can't have negative time. So this is not a solution. Now, if we check 45, that will definitely work. So what that means, how long does it take the faster computer to solve the secret of the universe working by itself? Well, that would mean 1 over 45 minus 9, because that was our faster computer. And 45 minus 9 is 36. So therefore, it would take the faster computer 36 minutes. Sorry for running out of room. So it takes the slower computer 45 minutes working alone. It takes the faster computer 36 minutes alone. One thing I realized I forgot to do in the last example, which I'm about to do now, we didn't state any restrictions. And these have a bit more complicated of a restriction. So we'll start with this one. If we look at this step, let's say right here, x can't be 0, x can't be 9. That's what we've been taught. But that would mean that x can be 1, it can be 2, it can be 3, it can be 4, it can be 5, basically anything outside of 0 and 9. But we just proved that if x is 4, it doesn't actually work in the context of the problem. So in actuality, this has to be a number bigger than 9, because 9 minus 9 would be 0. We can't have that. 9.1 though. So if we got x as 9.1, 9.1 minus 9 means it got 0.1. Fine, it takes 0.1 minutes. So our restriction for this actually is x has to be greater than 9. And that's our restriction. If we go back an example, now I can't go back without deleting all of this, but if you look back at your previous example of Peyton and Maya, we had 1 over x and 1 over 2x, and you can't have negative time, and x was negative time. So basically, it would have to be if Peyton takes half as long as Maya, the bare minimum would be 1 minute. So if you go back an example, your restriction would be x has to be greater than 0, is all that it has to be. Greater than 0 because you have to have at least some time. So again, these are a bit more challenging questions. I only gave you 2, and like I said, I can't give you a better hint than to say something like example 1 or example 2 is going to be on your test. Not both, but just one question like 1 or 2. And again, since it's an open book assessment, you definitely have a resource sitting in front of you. So your only seat work, that's it. Finish the rational portion of the package. See if you could answer either of these on your own without looking. And again, for your homework package, you just do as many as you need to. So by no means do you have to do the entire thing, just as many as you need to be successful. Next time you tune in, we will be working on the radical portion of this unit to finish off unit 1. And for your test, which as a reminder, your test is going to be Wednesday after lunch. And then you'll have your unit 2 test, which is just a shorter unit, Friday afternoon, probably after lunch again.